Good afternoon, everybody. Thanks for coming here. I think you heard a lot today about AI applications and new services that are launched and what you can do with your data. But there is one essential step that always goes first. What do you need to do AI or all of those services? You need data. And data is probably in data lakes, but it could also be in your core source systems. And if you are an automotive OEM, like Volkswagen, for example, the data is in ERP systems or on the shop floor, or on systems that are above your shop floor that contain the data. In our session today, we want to do this first essential step of integration, because the data is not always you want it where it should be and where you can then really analyze it and leverage all those AI services. And what we want to show you is a use case that we developed at Volkswagen, which integrates the ERP world, the SAP, with the shop floor. We is in this case me, Markus Grossmann. I'm Solution Architect Director for XL2. XL2 is a joint venture of Capgemini and Audi. And we are working especially in the area of production logistics, doing S4 transformations, analytics, and also cloud migrations. And together with me, I have Jan Sandmüller and Julian Michel. Jan is the product owner for the solution we are presenting you today, and Julian is the architect. So I'm happy that you're with me today. I'm located in Germany, in Heilbronn, working there with a really cool team. And what can you learn from this session today? You can imagine if you are in the production area, you usually have mission-critical systems. If there is a stop of those systems or any disturbance, it means that your production stops, and this could then have severe consequences. And so you could imagine that having integration of shop floor systems with other systems can be quite tricky. And what we also bring together here is the SAP world and the shop floor world, which is also often very different people, different knowledge, different skill sets, and you need to bridge this. And what we want to show you today is our guiding principles we used to find a solution for this integration of SAP with the shop floor, together with deep dives on our solution architecture. Really could be sometimes a bit technical, but really showing you what we implemented there together, then what we also saw as best practices and lessons learned from this integration. So our agenda will be that Jan will introduce you to the business case and the business background and also the challenges that were there. I will then talk about our solution approach and also the principles, and especially how we came to this side-by-side solution. Julian will then give you the deep dives into the solution architecture. And finally, we'll take a summary of what were the results of the solution and summarize the key takeaways. So for the business case overview, I'll hand over to Jan.
So, hello from me. I'm Jan. I'm from the Volkswagen plant in Baunatal. And I will say to you anything about our use case. So our use case is a part of a project called OneLog at Volkswagen. OneLog is an SAP S4 HANA business logistic template project. And one of the main goals for us is to harmonize material logistic processes. All processes are designed to meet the needs of the plants and to define corporate standards. Modern processes and IT systems are success factors for companies. The OneLog program creates modern processes for material logistics and has interfaces to other IT systems. VW has a lot of experience with its brands and plants all over the world. The OneLog project combines these experience and bring it into a new system called SAP S/4HANA. 4 plants are already using this SAP template from the OneLog project, and new features are still being developed. But it is now ready to use at the VW Group. Now, let's focus on the business process. VW planned orders in the production process for components in plants. So, in a component plant, VW don't produce cars, we produce components that we delivered to plants there produce cars. Components are produced on a production line. Different parts are produced in a sequence on this production line. At the end of the production line, there are production confirmation part created. This cannot be done by barcode scanning or counting manually. And that's why we need a technical interface to send production confirmations to SAP. But how do you, is my micro on? Yeah. But how do you realize the integration from the shop floor to the ERP? Let's take a look to both system landscapes. At the top, there's the enterprise resource planning process. Here's the order process. The SAP schedules the orders. The production begins to produce. A lot of confirmations, production confirmations are posted, and at the end, the order is completed. At the bottom, there's the shop floor level. At the shop floor level, there are the physical machines and physical production line. At the end of the production line, there are the production confirmations generated. Typically, the integration between the ERP and the shop floor are realized by a manufacturing execution system. But in our case, we don't have a manufacturing execution system. So that's why we need an individual solution to realize this case. You can probably guess that the solution is based on AWS because we are presenting it here at the AWS reInvent today. So let's move to the requirements and let's focus on the solution later. When it comes to a shop floor integration, we have some important goals for reliability and correctness. In many areas, we produce in a 3-shift system. So the solution must be designed for a 24 hours operation. there's a requirement to post all production confirmations on time. Otherwise, the ERP system will don't have the correct data and the production downtimes can be the result. Data posted during the interface must be accurate. Differences are not accepted. Components consumed in the production process must be matched in the stock from the warehouse. Otherwise, there's no guarantee that enough components will be for the next orders or for the next production. These requirements must be considered when implementing a solution. So let's have a look to our challenges. We have 3 main challenges. The first is flexibility. We bring a solution into a factory that exists, that's existing. There are machines, there are old machines, there's a brownfield scenario. We have greenfield, that's probably a better machine standard, but in the brownfield scenario, we must be very flexible. Existing machines will be integrated with SAP. So the machines don't support the SAP standard formats. They support other formats like OPCUA or MQTT or other formats. So we need a solution to convert these formats to the SAP standard format. So the next one is agility. Agility is a very important requirement for us because production processes can be changed on a short notice. New functionalities needs to be implemented quickly. This means we have a big focus on the agility. And the last part is scalability. When we started at the MVP, there are maybe 2,000 production confirmations per day. At this time, we are over 20,000 production confirmations per day. At the end of the rollout, we are up to scale up to 50,000 production confirmations per day on this plant. So, that's me. Back to Marcus.
But if you are searching for an integration approach of SAP in the shop floor, you do not have the problem that there is nothing. There is too much. If you are Googling for SAP, ERP, and shop floor integration, you get at least 40,000 results. And you have like shop floor management systems, you have different kind of middlewares, you have SAP connectors, or the typical ways to integrate SAP extensions, like in-app extensions or side-by-side extensions. You can have digital twin products, everything. And yeah, do you have the time really to study all those different options that you have? Weeks, months, maybe you could do it. We didn't want to do it. And so we tried to define principles that we said, these are our mandatory principles that should be used to decide on the right integration approach. They are inspired by our requirements. And what I will present you are those 3 principles. The first principle comes from modern SAP design, and it says, keep the core clean. And this means you should minimize the modifications of your SAP ERP systems to the bare minimum. That means your SAP Core should really be able to focus on the core business systems, and all around, all changes, modification should be done outside, where you could then also leverage cloud-based services for all those additional functionalities and use a modular approach. What is the benefit of keeping the core clean? Yeah, you could, for example, reuse pre-built integration solutions. So if you have an already working integration solution, you could reuse this in another plant or in your rollouts, or integrate it as a module to your existing SAP systems. So it's not an or direct part of the SAP system, but an extension. And there you could be faster, and you especially have less managing of those customizations. I think it was a study of McKinsey that says 10 to 20% of IT budgets are currently going into those, in the SAP systems, into maintaining those customizations, which is related to technical debt or managing this technical debt. And this is using a lot of expenses just to maintain the current situation and trying to run it. And it really blocks companies from doing really the innovations, because all extensions are difficult to test and it's a lot of effort. And so this is really a good thing then here, that if you keep those modifications out of the core, that you do not have to manage it, but have it in an external place with its own stack. And with this approach, you are then also easier to upgrade and do upgrades in this new module. So you're not dependent on any SAP systems. You can do it in parallel and also then introduce new features and capabilities in these extensions. And this gives you then also a future-proof architecture where you can have the flexibility, for example, also then to use AI services. The second principle, care for resilience. So we had resilience in the title of our talk. What means resilience? So you may know it from psychology, that if something very bad happens, you still can keep happy. And it's the same for the manufacturing area, that if you have a resilient system, it can withstand disturbances, survive disturbances. And there are a lot of other characteristics, like resilience means high availability, and high availability end-to-end across your whole integration chain. So it's not that you need high availability in your cloud service. If you need to, if you want to get data from the shop floor to your SAP system, every chain element must be highly available. And it should also support auto-scaling. So we heard about 20,000 to 50,000 production confirmations every day, and this could also vary and should be also scalable for the future. And this service needs to provide auto-scaling. It should reduce coupling, because if something breaks, then the impact of this disturbance should be isolated to a small module. And resilient also means you need monitoring, because, Werner Vogels already said everything fails all the time. And this also then needs error handling, including also automatic failovers in case of unforeseen disturbances. And the third principle is reuse standards where possible. This sounds like a no-brainer, of course. We do not want to reinvent the wheel all the time. We want to use proven, mature solutions that are ready to use and ready to integrate. But we should be honest to ourselves. How often do we neglect this truth? How often is it that our SAP system needs to comply to legal requirements, or there is, per customer wishes, a change, And this leads to a lot of isolated solutions in their silos with their complexity, and is going then away from being a standard solution. Now, these 3 principles, if you want to apply them now to this problem of finding integration solution, how to do it? The answer is, in the first design decision, implement it as a side-by-side extension. So this is also the recommended way from SAP for modern design of S/4HANA systems, to have the integration as an SAP extension. SAP says you should do it on the BTP, on the business technology platform, so it stays in the SAP world, but we'll see later it's also possible to do it in AWS. And the SAP extension is running in its own application stack, so we have 2 application stacks, one for the extension, one for the S4 system, and the extension is then using this interfaces and APIs of SAP to communicate and do data exchange with the SAP system. So it's really decoupled. And if you then have this SAP extension, you can, of course, do a lot. I know we all like the SAP UIs, but maybe you want to also have an improved version of an UI, or you have your users that are used to have their smartphones and having a mobile integration. So in this extension, you really have a lot of flexibility. You are not limited to SAP technology. You can use AWS, for example, for improved UIs, for process innovations, for doing data processing, doing data analytics, or AI services. So everything is possible here. But we still have this nasty dotted lines for the integration to the plant network. So how you're doing this? On the left side, you have this clean cloud network, everything fine. But on the right side is heterogeneous shop floor world with different machines, different vendors, a lot of difference. And here comes also why we decided for AWS. In Volkswagen, we have the so-called digital production platform. So it is AWS, or an initiative of AWS with Volkswagen, to create a default platform, a standard platform for the production logistics context. And this platform contains all the AWS services, and on top some additional services, for example, providing the plant connectivity. There's a service called the PCS, the Plant Connectivity Service, which is a highly available middleware, you could say, which is doing here the integration and also doing all the networking between the plant network and the cloud. And this side-by-side solution also then fits very well into this DPP platform layers or architecture that is defined here, which says we have a shop floor layer where all the machines and stations are. We have the AWS services on top. We have on top the platform services. And the SAP side-by-side solution is then an application that is built on top of this platform and which can then also deliver the integration with the enterprise software. And if we then check again, does this match our principles? Yes. We keep the core clean by having the side-by-side extension. We have the resilience by using the highly available and scalable AWS services. And this was also the key point. We are reusing a standard here that we have in Volkswagen. So we have solved this integration directly by reusing a solution that is built on top of AWS. So this was the approach. Then let's do some deep dives in the solution architecture.
Thank you. Thank you, Markus. So I will talk about the solution architecture of our application. Let's start with some key points here. First, you will find some figures here at the points, and they will be repeated in the solution architecture itself and on the following slides. So first, we implemented data ingestion layer. We are getting shop floor data, we are reading the data, we are converting them and validating the data. We have an interface to the SAP system where we communicate with SAP S/4HANA. We have built a resilient solution. We are ensuring data correctness. We implemented monitoring and alerting to make sure our application is resilient. Next, we have a serverless architecture. We're using asynchronous approach. We are using infrastructure as code. We're using CDK pipelines. And I will give you some best practices here. And at the end, I will talk about the development process and the team organization we are using for this kind of projects. So first, let's have a look at this technical slide. It's the solution architecture. On the left side, we have the shop floor zone, where we have a source system and the plant connectivity service that sends the shop floor data to the cloud. It's part of the DPP, Digital Production Platform, and it's used in general to integrate machine data, shop floor data to AWS. Next to it, you will find the first cloud account, and that's the data ingestion layer. The PCS component sends data to Kinesis. It will be processed by Kinesis Firehouse and sent to an S3 bucket. So there we will find our production confirmation. Jan already talked about. They are sent to this S3 bucket. The bucket has notifications enabled, so we were getting the events to an SNS topic, so it can be processed by multiple use cases or products. In the middle, the bigger screen is the solution architecture itself. That's the application we have developed. So first, we are reading the data into an SQS queue. It will be processed by a Lambda function. It's called parse file Lambda, where we are reading the file from the S3 bucket. We have two queues, that letter queue if there is an invalid file, and we have another queue called invalid entries queue. If there is just a single line that it's invalid, we are sending it to this queue. Data is stored in two DynamoDB tables. One of them contains the raw data. The other one contains aggregated data. Yeah, and the request is sent to another queue to be processed or sent to the SAP system. So there's a send data Lambda. It really sends the data to SAP. It's asynchronous here. Again, there is another dead letter queue if something went wrong, just in case something isn't available here. Yeah, and we have a quick site for reporting just to make sure everything works. We can do some correctness checks, for example, here. Data is sent to SAP. On the right side, there is a reverse proxy. I will talk about it in one of the next slides. Yeah, let's talk about the data ingestion layer first. We have four main elements here. So first, we are reading the source file that contains the production confirmation. So one file contains multiple confirmations, and we are reading the file, doing some validation here. So we are checking if there are invalid records. They are sent to the queues, and if there is a single record that is invalid, it doesn't affect the other messages or production confirmations here. That's really important to make sure the application still works if there is an invalid production confirmation or message here. We have implemented a duplicate check. So in case of a message is delivered twice to the AWS, it's not a problem. We can check duplicates in a single file. We can check duplicates compared to another file just to make sure one production confirmation is processed only once. And the fourth part here, we have implemented data mapping. So the shop floor format doesn't match the SAP format. Yeah, that's correct because there are different systems. We have implemented data mapping to make sure we are converting the source data to the SAP format. Now let's talk about the SAP interface itself. First, we have some design decisions here. We decided to use asynchronous communication, so the communication is decoupled. In case of the SAP system isn't available, we can still process messages. They will be queued and processed later. If some messages fail, we are sending it to a dead letter queue. We can use the dead letter queue redrive to reprocess again. It's quite useful if SAP system is not available. We can just reprocess them. The message aren't lost. And we implemented idempotent message delivery. So a standard SQS queue has an at least once message delivery. That means one message can send maybe 2 times to a consumer. Normally it happens only once, but it could happen that it will be sent 2 times. So we have implemented idempotent message processing in SAP. Each message has a GUID, and SAP recognizes if this GUID was already processed, then the message will be ignored if it will be sent a second time. So that's quite important to have the correct data later on. Now from a technical perspective, the SAP system is hosted in the on-prem network, so we had to make sure that the network connectivity is available. We have a dedicated network communication between AWS and the on-prem system. We have a reverse proxy for security purposes, so the Lambda function that sends data to SAP sends it to the reverse proxy, so there is no direct communication for security reasons. We have certificate-based authentication, so it's secure communication between AWS and SAP. In our case, we are using an SOAP service. It's integrated with the SAP application integration framework. We have an inbound monitor to see all messages, but you can also use, for example, SAP OData services as standard services to communicate with SAP in this case. Now let's talk about the concepts for resilience. We have implemented data validation concepts. We can analyze issues with AWS QuickSight, which is quite important for the operation of the solution. So first we implemented a QuickSight dashboard that shows all records that are sent or processed by this solution or interface. We can use it for daily monitoring, so we can compare the data in AWS to the source data to make sure everything was converted or transmitted correctly. Just in case, or maybe if there's a new feature, it's quite useful to have this kind of validation to make sure everything is correct. For example, if a new feature was added. Something that helped us a lot is some cross-system timestamps. So you need to make sure you can select the same data in both systems. If maybe one system has another timestamp like the other one, you need to make sure you have one format or one field to select the data if you want to really compare between the systems. We used some concepts for alerting. That's quite important. If there are invalid messages, this can happen. In this case, we need to handle them. So first, we have implemented alerting for the dead letter queues in our application. So if there is a message sent to a dead letter queue, we will be notified so we can handle this message. Another kind of alerting are reading the data from CloudWatch logs. If there are no CloudWatch logs, there is no data. That means something can be wrong in our application. Sometimes it's okay because there is no productions, but if there is production on the shop floor level and no data is sent, we have to analyze, okay, why is it missing? Is it okay? Is there an issue? Something like that. We also implemented time-based alerting. So if an issue still persists, nobody has worked on it, we are sending a notification again to make sure, somebody really resolves this kind of issue. We also notification end users like key user in the factory to make sure the business side can also handle those errors, or make sure they have some alternative processes so the real production isn't influenced by some issues, if they would be happen. Yeah, correct data is quite important. We already heard. We have implemented some data validation concepts. So we thought about how can we make sure data is correct and how can we make sure that we can approve that it's really correct. So we have some concepts like comparing data in the source system to the data in AWS itself. We can check if the data was sent to SAP to make sure really everything is correct. That's quite important. Also dealing with the duplicates was useful to make sure nothing was sent twice to one of the systems, that the data is correct. We also learned that SAP systems can have downtimes. For example, if there is a planned patch, the system isn't available for a few minutes or maybe a longer time. If it's a bigger update, it will be introduced. That's okay for us. We have the queues, so it doesn't affect our application, and we can send messages later if the system is available again. One recommendation from our point of view is to use loose coupling between AWS and SAP. So just use asynchronous communication. Make sure your application isn't affected if one application, maybe SAP, isn't available. The asynchronous communication makes sure that we can still process messages. They will be queued and processed later. AWS, in this case, works independent of SAP, so we can still process production confirmation if SAP isn't available. If it's available again, we can send them again, and no data is lost. The main business logic is separated from the SAP calls, so we can test the data or the conversion data without having an SAP system there. For example, when using unit tests, we can test our AWS logic, and later on, if everything works fine in our tests without SAP system, we can do an integration test with SAP, for example. We used infrastructure as code with CDK, and we are using pipelines as well. It's quite useful to provision our infrastructure. We have multiple accounts for testing and production, so we can deploy the same infrastructure there. We're using CDK pipelines. I think it's really simple to build pipelines with AWS CDK pipelines because they have some really great features like cross-account deployments we are using, for example. And in general, automation is really important. We want to have the same results in each account, in each system, and therefore we need to automate those deployment processes to make sure each account has the same configuration. How did we structure our deployments? So we're using CDK or CloudFormation, so we can deploy our application without downtimes. That's important because the application is used 24 hours a day. We're using one AWS account for each SAP target system. So we have a one-to-one connection here. That means for each SAP system, like production, SAP pre-production, or SAP integration, we have an AWS account. So it makes sense to have really a single AWS account here to test or deploy the application for this specific SAP system. Then we can also, if there are updates, we can just update our AWS account, our application that is connected to an SAP system that will be changed. So direct connection makes sense here. When talking about the team setup, from our perspective, it's quite useful to have a role as an integration manager. This integration manager is the bridge between AWS and SAP. They are completely different systems or solutions. That's okay, but we need to have a person that can understand AWS and SAP. So first, the technical view is important to do communication between the systems, but also talking about processes. You need to consider the end-to-end process from AWS to SAP, and therefore it makes sense to have a person that deals with those processes and the integration itself. The integration manager should also have access to both systems, so he should have access to AWS, access to SAP, to make sure if you are testing, there should be one person that can have a look in both systems, see if everything works as expected, and test is successful, for example. Another recommendation, focus on the technical integration first. If you're integrating AWS with SAP, you have a few challenges you need to resolve. So first of all, network connectivity. If you're building a connection from AWS to SAP, you need to make sure network connectivity is available. You have to talk to a security team to have the firewall configuration that the communication is allowed. You need to think about authentication. Which authentication mechanism are accepted from a security perspective, and you have to configure them. And the last point, SAP customizing. The SAP consultants have to do a lot of customizing configurations to make sure processes can be are available, and some interfaces like SOAP service or OData service is available to make sure everything is configured there so the communication can happen. And if you do it at the beginning, you have enough time to make sure everything is done when you really want to integrate the systems. So therefore, start at the beginning here. We do lots of tests in our application, and we try to use real data for testing. So if it's possible and allowed. In our case, we are using shop floor data. It's internal data, but it's no personal data, so we can use it for testing in a pre-prod system or integration system. That's quite useful. We can test with real data. We can find some issues earlier. So if we are implementing a new version, we can do a test in pre-prod stage. We use the same data as in production, and we can test or validate if we have the same results. If they are equal, we reassure everything works as expected, and we can do a product deployment to production. Yeah, that's it from solution architecture perspective. Now I will hand over to Markus again.
Thank you, Julian, for the technical details. And you saw it's not only technical details, we also have this human part in it, this team organization with this integration manager role. So I said in the beginning, the integration is the very first step. If you want to do something like data analysis, data lakes, you need to bring the data into the right location. And so if we then look, what are the results that we have here? We can say, yes, we have managed it. We have reached a reliable solution. It is highly stable. It has no data losses. It runs now over 2 years productive without disturbances, and can also work when there is, for example, a downtime of the SAP system. What was really important for us was to have really this agility, to be able to react quickly on requirements from the shop floor, like the change of data schemas, like new data getting here, because with all the integration, it's also with all the AI services. If you get garbage in, you get garbage out. No AI service will solve you this problem. It will always be bad data that you get. But if you are taking care for ensuring the correctness of your data and to be able to react on it by having this monitoring capabilities that Julian showed, then you are in good position. And also for us, it was really helpful to have this kind of monitoring, this agility to react quickly on required changes. And also if we see the operation from a cost perspective, there are advantages here. So we are not paying any BTP or SAP license costs for this integration solution. We have a pay-as-you-go model because we're using only serverless services. So I can't tell you differences now between a BTP solution and the AWS solution. We have not evaluated the BTP, as I said in the beginning. But for us, it's running quite good. And yeah, the solution is reusable also for other plants. And this is also the plan here currently, that we are rolling out this integration also to the other plants in Volkswagen. So we can say mission accomplished. We managed this integration interface and everything is good. But here starts the real advantage of the solution that we have, and also the integration of AWS, because with that we have now the shop floor data and the planning data both together, and we bring them together and can also use them together in the right place. We have new capabilities and we have even the chance to do more innovation in it. And this not only means that we can have this bi-directional data exchange, so not only sending the production confirmation to the SAP system, we can also do the other way around. So we can send the planning from the SAP and visualize it for the production worker, that he sees what is next to be produced. And if we think one step further, we now have the chance to really know what is happening on the shop floor. We have the situation here with the real numbers. We have the stocks, we have the number of produced items, we have trends of the produced items, and on top of this, we can then also establish innovations or solutions like having a recommendation service for the use of the SAP system. Give him more input, more data that is directly coming from the reality on the shop floor. So it's like a real-time system that we have here, that we get directly the feedbacks and can generate recommendations out of it. For example, if we have some supply chain disruption, that some of the parts are missing or you can't produce enough batteries, in this you can then also change your plannings of how many vehicles you can really produce. And you could then also think of AI-powered services, which can solve the problem of the increasing complexity of the production processes with electric vehicles, with the classic vehicles. And this is all very difficult and complex production setup that a single human cannot really find solutions for how to do the planning, how to change the production process. And here an AI-powered service that could monitor the data on the shop floor and could maybe implement an early warning system to detect supply chain disruptions. This could then also bring new capabilities to a solution. And this is by bringing together the data from the planning in the ERP system and the shop floor. So in short, what was our intention to show today? It was we have, with this SAP side-by-side solution, a reliable, highly scalable solution, which is a good choice for doing integration between SAP and the shop floor world. It supports a future-proof architecture where you can then also do or have the flexibility to do changes, and you have less issues with having a lot of customization in your SAP core. A key success factor was really that we have this platform in our shop floor, which is built on top of AWS, the so-called DPP, Digital Production Platform. this was already there, and we could leverage it. And also for this, we were very fast in developing this SAP integration solution. We had to do the integration between the AWS and the SAP, but this was much easier. And also, what I wanted to mention here, it is not only about technology or technical solutions. You also have to think about the integration of the different skill or knowledge worlds with the SAP and the shop floor world to establish roles that are in between. The last word should be with the customer. And so, Jan, handing over to you again for final words.
Thanks, Markus. So it's the last hour. We heard a lot of solution architecture, business process, shop floor integration, and anything else. So I would say we at Volkswagen are very proud of this solution based on AWS. It's a very good solution and a perfect way to fix our problems with the shop floor and the ERP. Before we come to the Q&A, I want to say thank you. There's one person that can't be here, but it's a very important person. He is the one from the first hour, and I want to say thank you to Christian. Thank you that you are one of the team and the solution, and thanks to Julian and Markus. And now, there is here Q&A. I think we do a Q&A talk over there. And yeah, that's it.